Okay, good afternoon. So, in the last lecture, we have started the point of the in the unit number 3, that is the durability of the concrete, and we have general discussion we have done about the durability of concrete and some consequences of the improper quality and inadequate durability we have seen. That is the this loss of strength of concrete, then concrete liable to be easily affected, then corrosion of the rebar, loss of the serviceability, unpleasant appearance, then expensive repair costs, poor perception of agency involved, reduction of the service life. So these all again alkali aggregate reactions. So these are the inadequate durability, consequences of the inadequate durability. So so if you see these some pictures, these are the some consequences of the inadequate durability. So if you see the structure, the beam is have damaged. Here the slab portion has damaged exposure of the steel. Again, if you see here, this wall is damaged, or here in the page, in the image number second, if you see the whatever concrete placed in the column, that concrete the honeycombs are present, and the steel are open if you de-shuttering of the for the column. So such conditions happen due to that the inadequate durability consequences happen. So again, if you see here, the half of the building is damaged, or they have collapsed, demolition of the half of the building here in second sketch. So here corrosion of the steel also, if you see here. So the some of the factors are influencing about the durability of the concrete. That factors are the environment, quality of the consistency of the materials, water cement ratio, workmanship, then cover embedded to the steel, and shape and size of the member. So the durability is again depends on the two factor. So one is the concrete system, and another one is the service environment. So the concrete system is generally based on the quality and quantity of the material used. So concrete system, so durability depends on concrete and environment. These two are the main factor, but the concrete system is based on the quality and quantity of the materials used. Whatever materials we are using for the mixing, manufacturing of the concrete, that is the cement, sand, aggregate. So these materials you are using. So the quality and quantity of these materials are the matter to the durability of the concrete, and some of the processes involved in manufacturing of the concrete. So how you are manufacturing of the concrete, which type of method you are using to manufacturing of concrete. Either you are concreting by hand, either you are concreting by mixer, or you are concreting, you are purchasing concrete for RMC plant. So whatever procedure you are following for the manufacturing of concrete, so these two main quality and quantity of material and process involved for manufacture of cement, so these 2 points we have to consider uh, uh, when the concrete system is the main factor we are thinking about the durability. Then second is the service environment affects the concrete. So environmental conditions are also important for the durability of the concrete. So physical action and chemical action. So see, physical action, some of the vibrations of any nearby your building. So if you have constructed the building, concrete building, so due to some impact load on the slab, due to some other vibrations nearby building, these are the physical actions, or earthquake. So these are the physical, and some chemical actions are there. So due to some chemical as a water, so water is saturated on the water is stored on the slab, so then that insert into the concrete, so the corrosion takes place of the steel. Then sulfate and chloride attack will be there due to the drainage. So in the drainage, some of the chemical reactions are there, drainage water. So that affects the chemical actions on the concrete. So these are the two main factors we have to consider while the durability we have to consider. So then if you see about the here concrete system and the environment, service of the environment. So material in the concrete system, material and process. So what are the material? Binder type, binder constant, aggregate, admixture, mixed design. These are the materials. And process of the manufacturing of concrete is mixing, transportation, compaction, curing, temperature. So these are the methods or processes we have to actually we are doing while manufacturing of the concrete. So again here service of the environment. So physical and chemical, as I told, the abrasion, erosion, cavitation, it means vibrations of some other building excavations are on the same building. And the chemicals, some chemicals attacks will be there on the concrete and steel also. So these are the factors affecting the durability of concrete. So materials. So which type of materials we are using? So we are using materials, the cement we are using for the making the concrete, sand, aggregates, water, admixtures. So these materials we are using for the manufacturing of the concrete. So the selection of this quality of material is a very, very important. So the cement. So there are many more properties of cement. Physical properties are there. Consistency of cement, initial setting time, final setting time, specific gravity, soundness, compression strength. So these are the properties of the physical property of the cement, and are that physical properties are depends on the, if the quality of material is there, that physical property will be within the limit. Again same sand is there, so there is some requirement, Indian standard requirements are there. Stand is how much percentage of fineness modulus of sand is there, then how much silt content we should be present into the sand, not more than that. So such IS requirements are there, and as per the IS requirement, the materials we have to use, and that materials are the good quality materials. Again water is again very, very important. That water we have to use the pH value less between the 6 to 8. So the potable water we are drinking, so that potable water we should use for the construction also. Then aggregates also we are using. So aggregates are the cubical shape aggregates, so elongation index and flakiness index also we have to think about that. So all these 4 5 materials which we are using for the manufacturing of concrete, that materials are should be the good quality of materials. So that selection is very important. So again the capability of the cement and plasticizer. So whatever admixtures you are using into the concrete, so that admixtures we have to use for as a specific as per the requirement, should not add more or less admixtures, so that the durability of the concrete will be takes place. Then unsound materials, which are the unsound materials. So the cement on aggregate is considered unsound material. Why? Because they causes the unacceptable volume change, or hardened concrete or mortar, which cause the cracks and affects the durability. Why we are calling cement and aggregate as an unsound material? Because these two materials are they causes the unacceptable volume change. Sometimes volume change will be there of that material. Then again hardened concrete will be there. So mortar, which cause the cracks and affects the durability. If the cracks happens, or if the cracks developed for the structure, then the durability will affect uh, or affect the durability of the concrete also. Then aggregate containing the certain materials such as the shale, clay, slump, coal, iron. So these all the unsound materials are there, and that drying or freezing and throwing. So the more moisture absorption in aggregate. So the generally aggregates are absorbing the water which we have added for the mixing purpose. So that whatever water we are adding into the concrete, those The maximum water absorption of this admixture should not be greater than 2 to 3%. So 2 ते 3% जास्त water absorb aggregate न केलं नाही पाहिजे. If water will aggregates will absorb the water, then your quality of the concrete will be low and the durability of concrete will affect. So this is the water permissible limit for the solid. So if the organic or inorganic or sulfate, chloride and suspended matters are there, that the tested as per this particular IS code, and the water, whatever water we are adding, the permissible limits for this water are this. So the organic content 200 mg per liter maximum, then inorganic 3000 mg per liter maximum permissible limit, then sulfate and chloride 400 and 2000 mg per liter, and suspended matter 2000 mg per liter. So these are the requirement of standard water as per the IS 456/2000. So the impact of water cement ratio on the durability. So the very important factor is the water cement ratio, and it will affect the workability and finally strength from the durability. So what is the impact of water cement ratio? So the permeability and contributory factor for the volume change and higher water cement ratio is a fundamental cause of the higher permeability. So if you think about the water cement ratio, so why we have to think more about the water cement ratio? Because if you add the more water, then the workability of concrete will be reduces. If the workability of concrete will be reduces, then the durability of concrete will be decreases. So the finally durability is a very important. Durability is nothing but the life of structure. किती वर्षे आपलं स्ट्रक्चर जे टिकणार आहे किंवा त्याची क्वालिटी मेंटेन राहणार आहे विदाउट डॅमेज, ते म्हणजे ड्युरॅबिलिटी आहे. आणि दॅट ड्युरॅबिलिटी, if we have to maintain that durability, then water cement ratio also we have to consider. So if use of higher water cement ratio, the permeability will be increases and volume change will be there. Change in volume will be there. Then the cracks will be there and disintegration and the failure of concrete will be there. So for this durable concrete, we have to use the lower water cement ratio possible. As possible, we have to use the lower water cement ratio. And the fundamental requirement to produce the dense and impermeable concrete. So the modern super plasticizer admixtures that we are using for the to maintain the water cement ratio, or to maintain the water cement ratio and increase the slum more than 250. So the super plasticizer we can use if we have to maintain the water cement ratio. Then this graph you can show the permeability versus the water cement ratio. So the water cement ratio is a very important factor which is affects on the durability. And if water cement ratio, if we can maintain the permeability, is again very important. So this graph, if you see, on the x-axis the porosity they have given, and on the y-axis they have shown the coefficient of the permeability. So the water cement ratio and permeability graph here shown. Then the processes, which how we are following the process of manufacturing of the cement. So manufacturing of the concrete. So workmanship for the durable concrete. See, the concrete we have prepared good, but we are preparing concrete in good quality. But if the workmanship is a very low quality, workmanship is not proper, then your durability will be decreases. So what proper workmanship you have to follow for manufacturing of concrete? So the batching means mixing of concrete. Batching, initially we mix the concrete in dry state, then we mix the concrete in the so if The workmanship is nothing but we are mixing the concrete in the dry state first, then we are adding into the water into that. So the batching, mixing, then we are transporting the concrete on the particular column, up to the column, up to the beam on the slab, or through RMC, from the RMC plant through vehicle, then placing. So the we are placing the concrete on the in the particular component. There may be a column, there may be a beam, or there may be a slab. So in the that structural component we are placing the concrete, that concrete we have to place as per the some guidelines for the placing, as we have learned in the concrete technology also. Then compaction. After placing, we have to compact the concrete so that we can reduce the porosity of the concrete. So if you vibrate the concrete, then your concrete will so air voids will be removed, or air voids get reduced. So the compaction is again very important. Then finishing. If we de-shuttering the component, if some finishings are required, that finishing we have to do. Then protection. So concrete, we should give the protection to the concrete, and curing is a very important factors which affects the durability of the concrete. So curing is a very important. So generally 30% strength will be increases if we cure the concrete. जितकं पाणी तुम्ही नंतर वापराल, curing is a very important. 30 to 40% strength will be increases by the curing. So these all the factors which we have to consider as a workmanship. कारण का आपण कॉन्क्रीट करत असताना आपल्या हातून हे घडणाऱ्या सगळ्या गोष्टी आहेत, and that affects the durability of concrete. So then compaction of the concrete. So as I told, as we have learned in the unit number 2, compaction. No, this in this unit also, compaction of the concrete. So there are various methods of compaction of concrete. So we have to use any method. So we have to use needle vibrator, table vibrator, then surface vibrator. These all the vibrators we have to use for the compaction of the concrete also. So we have to ensure that the suitable workability, employing appropriate placing and the compaction environment. So adequate compaction without segregation. So that you have to, so adequate compaction. So if we do the more compaction, then segregation will be there. So without segregation, you have to do the adequate compaction. So again, the 1% of the voids reduce strength by the 5%. So 1% voids reduces the strength by 5%. So as I told, the curing. So curing is a very important. So if the extremely important, if the water cement ratio is low and the cement content is high, then if cement has a high rate of the strength development again, so ambient temperature will be during the placing is high, and the day is windy. So the curing is very important. As I told, the 30 to 40% strength will be increases by the curing. So the recommended curing for the normal weather condition are the, for the OPC based concrete is 7 days, blended cement based concrete 10 days, then harsh weather condition or hot or dry condition will be is there, then we have to use the we have to provide the curing for the 10 days, and blended cement we have to use the 14 days. So the cracks on the concrete surface due to the inadequate curing. So if we do the inadequate curing, then the cracks on the concrete surface will be shown. So if you see this particular sketch, the cracks on the concrete will be shown if you do the inadequate curing. So then the environmental condition. Okay, then the environmental condition which affects the affects on the concrete. See, so the environment can classified again into two groups as we have discussed, the physical and chemical. So the physical classification is the temperature of outside temperature during the nearby building area where we are concreting, then the moisture presence, then the alternate wetting and the freezing and throwing also. Then chemical, some attacks will be there, that is the acidic, then alkaline, corrosive. So the physical environments attacks the affecting the durability. So how the physical environment will attack on the durability of the concrete? So the temperature. So the temperature will affects the rate of hydration of the cement. So the very important part is the rate of hydration. So if we add, if we cure the water, curing process, we are after the placing, we are applying the from next day onwards after setting time, we are giving additional water to the for the as a curing. So the that rate of hydration will be, if the temperature is more, that water whatever we are providing for the curing purpose, so the rate of hydration will be decreases. Then the leads to plastic shrinkage, crack, then volume change and cracking, especially in mass concrete. Then again spalling and disintegration of concrete at higher temperature, and the variation of the temperature causes the secondary stresses. If the temperature is more, then heat of hydration will be decreases, then plastic shrinkage, cracks will be noticed, then change in volume of the concrete will be noticed, then spalling and disintegration of concrete at the higher temperature, that will be noticed, and the secondary stresses also uh, developed in the concrete. So that is due to the temperature. So then the moisture in the environment. So the shrinkage on the drying and consequent volume change and cracking will be due to the moisture present in the environment. Then induces corrosion of steel. If the moisture is present on the concrete or environment, the corrosion of steel will be started. Then again the some causes of explorants and deposition of uh, calcium, CaO plus H2. So the seepage oblique leakage cause the inconvenience to occupant and the deteriorates structures due to permeable concretes also there. So then the physical environment impact. So alternate wetting and drying so causes the secondary stresses. So as I told, secondary stresses will be caused due to the some physical environmental condition also. So then they accelerate the corrosion of the steel also, then chemical attack on the concretes also. So the freezing and throwing, that is the one of the physical environment that leads to the expansion of concrete and cracking. Ice melting, salt is there that causes the erosion of the concrete also. So then chemical environment attack. So we have seen physical environment attack, now chemical environment attack. So when we are dealing with the durability, then the chemical attack which results in change in volume of the concrete, then cracking, then consequent of deterioration of the concrete becomes a major cause of the concern. So type of chemical attacks are on the concretes are sulfate attack, alkali aggregate reactions, then chloride ion attack, then carbonation, then acid attack, and the effect of on concrete in seawater. So generally in seawater, there will be a your structure will be contact with the water, and the water is very dangerous. External water is very dangerous to attack on the chemical attack on the concrete and steel also. So these all the 5 6 are the chemical attack on the concrete. So sulfate alkali aggregate reaction, then chloride ion attack, that is the corrosion, due to the chloride iron attack, the corrosion will take place. Then carbonation of concrete is again there. Then acid attack and the effect on the concrete and CO2. So these are the types of chemical attack. So sulfate attack. So as first is the sulfate attack. So sulfate attack denotes the increase in the volume of the cement paste in the concrete. Increase in the volume of cement paste in the concrete or mortar due to the chemical action. Then in hardened concrete, generally the calcium aluminate hydrates and that can react with the sulfate salt from the outside, and the product of reaction is a calcium sulfonamate that which can cause the increase in the volume up to the 227%. 227% the volume will be increased. The rate of sulfate attack increases with the saturated sulfate solution. Then again, if we talk about the sulfate attack, the method of controlling sulfate attack is use of SRC. The method of controlling sulfate attack is the use of SRC. Then the quality of concrete, the low water cement ratio or well designed and compacted dense concrete is there. The use of air entrainment and the use of pozzolana, again the high pressure steam curing and use of high alumina cement, that we have to that methods we have to controlling the sulfate attack. So then the alkali aggregate reactions. So have you seen sometimes the concrete will see such color? I think very you have seen many more. So such you can such images you can see near the toilet area where the toilet water is on the concrete surface. So there you have seen this alkali aggregate reaction. So the alkali from cement and react with the silica to form alkali silica gel of the unlimited swelling type. So the continuous growth of this silica gel extract the what we can say that osmotic pressure within the concrete. So the occurrence is due to, so how this alkali aggregate reaction takes place. So this the occurrence is due to the high alkali content in cement. High alkali content in cement more than 0.6%. Then reactive silica in aggregate, availability of moisture. So this is again related to alkali aggregate reactions. That alkali aggregate reactions is a basically chemical reactions between the hydroxyl ion in the pore water within concrete and certain type of the rock metal. So again, it is recognized as one of the major cause of the cracking of the concrete. So alkali aggregate, due to the alkali aggregate reaction, the causes the cracking of the concrete. Then again, this alkali aggregate reaction produces the alkali silica gel of the unlimited swelling type under the favorable conditions of the moisture and temperature. The crack width can range from 0.1 mm to as much as 10 mm. So these alkali aggregate reactions cause the so many factors, that is the cracking of the concrete, then moisture and the temperature, condition of the moisture and temperature, then the crack width can range of the 0.1 mm to 0.1 mm to 10 mm. So this will happen due to this alkali aggregate reaction. So then the chloride content in the concrete. So if chloride content is chloride in concrete increases the risk of corrosion of steel. So chloride in concrete increases the risk of corrosion of steel. So that is the as per the IS 456 2000. So if the chloride content will be increases, or chloride content coming to the nearby chloride attack will be on the concrete, Then exposure to warm, moist condition increase the risk of corrosion. So as I seen in the last two slide before, see if the chloride content will be increases into the concrete or on the concrete surface, the corrosion of steel will be the risk, will be the risk. And again, to minimize the chance of corrosion, the level of the chloride in concrete should be limited. Also, the amount of chloride content in the concrete at the time of the placing is provided as per the IS 4.6. So methods to or methods of controlling the chlorides. How we can control the chloride content into the concrete so that we can avoid the corrosion of the steel. So generally chlorides in the cement to be less than the 0.1% of the max. Repeating, so chloride in the cement is to be less than 0.1%, and that chloride in water to be less than 2000 mg per liter for the PCC and below 500 mg per liter for the RCC. So see, so this is the very important. So chloride in the water, this is very important for the MCQ examination. So the chloride in the water to be less than 2000 mg per liter for the PCC and below 500 mg per liter for the RCC. Again, the chloride in the aggregates are generally not encouraged, but it's a good practice to wash sand containing salts more than 3%. So chloride traces are also found in the chemical admixtures, and the chloride free admixture should be generally prepared so that we can control the corrosion or avoid the corrosion. So how corrosion will take place? So the corrosion is again the electrochemical process, and the basic mechanism for this the electrochemical process is the for the different area, the same steel bar of the anode and cathode, their electrical connections being maintained by the pore water, which acts the electrolyte, and steel releases the election and takes the ionic form. So that is related, and at the anode, the water in the presence of oxygen and release the electrons from the hydraulic ions. So examples of the delamination of the concrete cover. So the how this happens, if the chloride content is more, then your steel will be corrugated, and if steel corroded, then the steel and concrete bond will be released, and the bottom cover of the slab or any concrete element will be spalling. So this is the volume of the corrosion. So then again, if you see the cracks formed due to the bursting pressure of the account of rusting of the reinforcement. Then methods of controlling of corrosion. So what are the methods to control the corrosion? So the limit the chlorides in water, cement, and superplasticizer, etc., to acceptable levels. So provide the proper cover as per the IS norms. Then cover blocks also need to be of good quality. Then concrete should be properly compacted, and we should make the dense and impermeable or the waterproof concrete. So these are the methods we have, methods of controlling the corrosions. So then the carbonation of concrete. So how the carbonation of concrete will take place? So mechanism for the carbonation of concrete will be the carbon dioxide from the air react will be the calcium hydroxide to form the calcium carbonates, and in the presence of moisture, the carbonic acid is formed with which reduces the alkalinity of the concrete, and the pH value of the concrete reduces from the 12.5 to 9. So the rate of hydration, sorry, rate of carbonation depends on the relative humidity and grade of the concrete, also the permeability of the concrete and depth of the core. So nearly 1 mm carbonation is reported per year in the normal M20 grade concrete. So this is the this is about to carbonation of concrete. So measurement of depth of carbonation of concrete. So it is a very easy method to measurement of the depth of carbonation. So here, if you see in this particular figure, so pink color indicate that um, the presence of that yes, O2, CaO2, and in uh, this, if we see here, the concrete is unaffected by CO2. If you see the pink color, so the pink color area is a concrete is affected by CO2, and the second the bar, if you see here bar, concrete is a carbonated. So if we talk about the carbonation again, so the carbonation of concrete is again a process by which the carbon dioxide from the air penetrate into the concrete. So carbon dioxide from the air penetrate into the concrete, that is the carbonation process, and it react with the calcium hydroxide to form a calcium carbonates. So this is carbonation is a very so easy. So carbonation of the concrete is a process by which the carbon dioxides from the air which penetrate into the concrete and react with the calcium hydroxide to form a calcium carbonate. And in the actual practice, the carbon dioxide presence in the atmosphere permits into the concrete and carbonate the concrete and reduce the alkalinity of the concrete. So CaOH2 has become carbonated and the pH value will be reduced up to the 8.3. So in such a case, the low pH value, the protective layer get destroyed and the steel is exposed to the corrosion. So again, the highest rate of carbonation occurs the relative humidity between 50 to 70%, and protective coating is required to given for the long span bridge, girders, then flyovers, then industrial structures and chimney also. So the deep cover plays an important role in the protecting the steel from the carbonation. So steel in a passivity condition. So if you see here the stage, the steel bar is in the concrete. So the concrete is under continuous attack by the aggressive environment agencies, and the good concrete and sufficient cover is to answer for the durability. And the last is the acid attack. So acid attack on the concrete. So generally concrete is not fully resistant to acids depending upon the type and concentration of acid. So oxalic acid and phosphoric acid are the harmless, and the most vulnerable part of the cement hydrate is the CaOH2. So the concrete can be attacked by the liquid with pH value less than 6.5. That is the acid attack. So the acid attack is served only at the pH value below 5.5. See, if the pH value is below 5.5, then the acid attack will be there, and that pH value will below 4.5. The attack is a very severe. जितका ऍसिड पीएच व्हॅल्यू तुमची कमी होत जाईल तेवढं तुमचं अटॅक जो आहे ऍसिडचा हा सिव्हिअर होत जाईल. And that cement compounds are eventually broken down and leached away. So if acids are able to reach the reinforcing steel, then the cracks corrosion can occur, the leading for the further crack. So the cover for the reinforcement. So cover for the reinforcement is again very important environmental condition we have to follow. So the cover to the reinforcement as per the IS, that is the minimum nominal cover for the mild is 20, then moderate 30, then severe is 45, very severe is 50, and extreme is 45. So for the main reinforcement up to 12 mm diameter for mild exposure, the nominal cover may be reduced by 5 mm. So the nominal cover by plus 10 mm or 0 mm we have to provide as per the IS 456 2000. Then the impact of other material. So what other material impacting the durability of the concrete? So mineral oils. So usually the effect only fresh concrete in their hardening process. So petrol, petroleum. So these will affect on the fresh concrete. And then the organic acids that have that organic acids we due to that organic acids the corrosion will be there. Then vegetable and animal oils and fats, so that causes the deterioration of the concrete surfaces due to their corrosive actions. Then action of the sugar, so the sugar has a retarding effect on the fresh concrete and has a gradual corrosive effect. So action of sewage. So concrete sewer running full remain unaffected, but in the partially filled sewer where the hydrogen sulfate gas is involved and sulfuric acid is involved. So this is up to the effect of the other material. And then next point is the fire resistance. So the last point of this particular unit number 3 is the fire resistance. So generally the concrete is resisting to the fire, but steel is not resisting to the fire. But generally steel we are providing inside the concrete. So external part is the concrete. So the best fire resistance aggregates amongst the igneous rock are the basalt and dolerites, less amount of the silica. In the basalt rock and dolerites rock, the less basalt, so less silica is present, then that is the best suitable aggregate for the fire, and that aggregate we are using into the concrete. So generally we have seen, you have seen the aggregates are from the basalt rock only. So these are the good fire resisting aggregates. So then the decomposition takes place only at the very high temperature of the 900 degrees Celsius. So the limestone is considered as a good fire resistance aggregate. So स्टोनला जर वितळवायचं म्हणलं तर 900 डिग्री सेल्सिअस इतकं टेम्परेचर लागते तुम्हाला लाइमस्टोनला. सो 900 डिग्री सेल्सिअस टेम्परेचर इज नॉट अ लेस टेम्परेचर, it is very high temperature. So that much high temperature is required to melt your stone or your aggregate. So the limestone is also good for the resisting the fire. Then serious reactions in the strength occurs at the temperature of about 600 degrees Celsius. So constraint and some issues for the concrete in aggressive environments are the contaminant in the soil, water like sulfate, chloride, effluent, etc. And highly affect the durability of concrete is that is the limitations of the SRC. So heavy reduction in the hard room space due to large depth of the bead is also the issue related to aggressive concrete in the aggressive environment. Then again, limitations of OPC leading to weak micropore structures, and large dimension of column in particular leads to space constraint. So these are the some issue or constraint for the concrete in the aggressive environment. So why it is necessary? So why it is necessary? So that is the intense competitive environment, then the entry of foreign goods and services, then increase the customer consciousness, then earning profit instead of the making profit, and the organization's survival or progress depends on it. So these are the some quality necessary for the concretes. So this is nothing but the durability of the concrete and the fire resistance of the concrete. So here end of the unit number 3. So next lecture onwards we will start the unit number 4, and so we will stop here today, and we will see the unit number 4 in the next lecture. So wait, I will take attendance then.